Let's solve Leetcode 1475 final prices with a special discount in a shop. So we are given an integer array prices where prices I is the price of the ith item in the shop. Okay, that's fair enough. There is a special discount for items in the shop. If you buy the ith item, then you will receive a discount equivalent to prices J, where J is the minimum index such that J is greater than I and prices J is less than or equal to. Make sure we remember that. Less than or equal to prices I. Otherwise, you will not receive any discount at all. Return an integer array answer where answer I is the final price you pay for the item of the shop, considering the special discount. Okay? Let's go over this first example. So prices is 8, 4, 6, 2, and 3, and they want to know, considering this special discount, what would the list of prices look like after the discounts are applied? Okay, so looking at 8, they want to know, looking past 8, which is the first number that is less than 8, and then you can subtract that from 8, and that would be your discount. So the first number past 8 is 4, and so 8 minus 4 is 4, so that's why they have this first 4 here. Moving on, 4. The first value past 4 that's less than 4 is 2. So we can subtract 4 minus 2 and we get 2, which is here. Next value is 6. And the first value after 6 that is less than it or equal to it is 2. 6 minus 2 is 4, so that's what we get here. 2, if we're looking for an element past 2 that is less than 2, it does not exist in this array or list. Same thing for 3. So that's why these two remain unchanged. So this is the returned value, or what is expected. Okay, I think that's straightforward. So let's get started on it. I think what we'll do is we'll use a monotonic stack, and I think that will help out. So let's go over this here. Let's actually use this here. Okay, let's get started here. Okay, we'll call this nums or prices. Okay, so what we'll do is we'll add numbers, and we'll keep adding on to the numbers. And if we don't, okay, we will maintain a stack that will store, we'll call it like increasing values. And once we encounter a value less than top of stack, we will pop and then place back into, we'll call it some new list with discount applied. Okay, so we will maintain a stack that will store increasing values. Once we encounter a value less than the top of the stack, we will pop and then place back or place into a new list with the discount applied. Okay, and we're actually going to put this in a while loop right here. So we'll keep doing this while this is true. Once we encounter a value less than the top of the stack, we'll put this in a while loop. This will be in a while loop here. All right, so let's go over, let's walk through this one here. So let's look at 8. So 8, well, that's fine. It's just a single element. We haven't seen any other numbers yet. Fine. So this is our stack right now. That's our stack. Well, I mean, currently, our current number was 8. Current current number was 8 first, and then our stack was empty. Then our stack was empty. So we don't need to do anything. So then we carry on. The next number is 4, and at this point the stack is 8. So we're always checking this. If we encounter a value less than the top of the stack. So in this case, it is. So we'll pop it out. So what we'll do is we'll create maybe a new list. So we'll call this maybe we'll just call it new list for now. I don't want to call it that. I'll just call it. I'll just call it alpha. This will be our new list. New list with discounts applied. Okay. So we first, here's 4, and then we have an 8 on the stack. So we can say, well, this is the first value first value after 8, and it's less than 8, so we can apply the discount. So we can say, okay, we'll say L of, so this was stored at, well, we need to maybe even store what index it's found. So what we can do is store the value and maybe the index of where it's located. So when we pop it off, we can say, okay, L of 0 equals 8. Maybe that'll work. Yeah, that's fine. Yeah. Sorry, 8 minus the value, which means now L would be 4. Yes. So this is the current value. So on the stack it's 8 and 4 is current. So 8 minus 4. This is the discount applied. And now we go to the next number. The next number is 6. So current equals 6, and stack equals. So we're gonna add 4 to the stack. So 4 and where it's located. So that's 1. Okay. Now 6 is not less than 4, so we don't need to apply the discount. Not yet. And then we move on to the next one. So now current equals 2, and our stack will have still has 4 and 1. So the 4 at index 1, and now it would have also 6 at index 2. So in this case, 2 is less than, this is the top of the stack currently. So 2 is less than the top of the stack, so then we pop it. So then we say, okay, when we pop it, we say, okay, you're at index 2. So I can say, okay, at index 2, I'm going to have 6 minus 2, which equals 4. So that would go here. So I'm going to leave a space, and I'm put a 4 here. Okay. But then remember, we're going to perform this action in a while loop. So we do the same thing. We say now L of 1 now. So this 1 goes here. And then we do that value minus the current one, which equals 2. So that means in our list at index 1, we put a 2. Okay, great. Things are looking good. We carry on now. So now we're at current equals, let's move this down. So current equals 2. Current equals, is that right? No, sorry, we're already at 2. We go to 3. So current equals 3. Stack equals, and so remember we popped both of these off, which means the stack is empty, but then we need to add the 2 here. So the 2 would be here. So it would be 2 comma, what, 3? The index, 0, 1, 2, 3, yeah, that's fine. And 3 is not less than 2, so we don't do anything. So we just add it. We just add we add 3 to the stack, and now we would have was it 3 comma 4. Okay, so we have our list, but then we still have elements in their stack. So what we'll do is we'll loop through this, and we'll add the 3 and the 4 to the list, to the new list. So we'll just say L. So if elements remaining on stack, add them to the new discount list and return. So we'll just go loop to this and add 3 and 4 to the new list. And so we'll say, okay, L So then L would equal whatever it is. So it's this thing here, 424, 424, 2, 3, 2, 3. I think that's right. Yeah, okay. And that's, I think that's what they had in the example. 42423. Okay, great. So I think that's enough to get started. So let's do it. Let's code it up. Okay, so we'll initialize a stack and a new list. So we'll call this, the stack will equal this, and we'll just call this I don't know, we'll call it new, just call it L for now, and we'll also set it like this. And what we'll do is we want to remember, we'll know where, when we place the element, for example, when we had something like, I think it was 6, we placed this 4 at this location here. So what we'll do is we'll set the size of this to the length of prices. Just as a little note, at the end I'll probably optimize it, not optimize it, but just rewrite it so it's a little bit just, what's the word, more direct. So this is just like, I think it's more easier to understand, and my next iteration or my next version I'll probably just write it so it's a little bit more straightforward. Okay, but this is fine for now. So for I, P, and enumerate prices. Okay, so what do we want to do? We want to say, so remember we're always checking if there's a value less, if the current number is less than the top element of the stack. So the current number right now is P. So we need to check if that's less than the top number of the stack. So while stack, so this means if there's an element in the stack, and P is less than the top of the stack, so S of -1. And remember, we're storing 2 values on the stack, the value and the index. So let's store, maybe we'll just store the value here, it's fine. So if it's less than that, we'll pop it off. So we'll pop it off. So we'll say s dot pop, and the first value of the stack will have the index, sorry, the value, and the second value will have the index. So we'll just say value and the index. Okay, should be fine. Okay, let's do price here instead. And then now we need to add this to our list here. So we say L of that index, and what do we put there? So we want to put the price minus the discount. So the price minus the discount, which is that current number. So remember up here when we had like in this case, the current number was 4. When we popped off 8, it was that 8 then minus that current number. That's the discount. So essentially this is afterwards. Okay, I think this is good. And then now we can add that current number to the stack. So we say s.append. So remember, we're adding the price and the index. So in this format, that would be p comma I from up here. Okay. And then what do we need to do? So we've gone through the loop, and now there are no more elements to check. But remember though, sometimes we may have still elements remaining on the stack, so we need to add them to the list. So we can do something like for maybe we'll call this P and I in S. So remember, we're always storing the price and the index first. Sorry, price first, index second. So we can say, okay, L of the index will equal the price. And remember, these elements will not have a discount applied. And that should be it. Then we can just return L. Okay, let's check it. What went wrong here? Oh, yes. The thing I told you to remember, I forgot. It's less than or equals to. And if you look at what I did was I only used less than. So we need to change that. So yeah, so this would be less than or equal to. My apologies. Okay, so that looks good. And then let's submit it. All right, that's that's already fast. It's 2 milliseconds. So but let's just see how we can change this up a little bit. You can probably stop watching the video now. It's not going to make much of a difference, but let's do something like this here. So in our stack, notice how we're holding the price and the index. What if we just store the index? So let's change that. So that means we don't need to use L anymore. So let's take off L. And I'm going to change prices to maybe I'll just change it to capital P. And okay. And then we'll say okay for I think we can just do this here. Let's see. Trying to think. Maybe I in range length of P. Okay. So then we'll stay while S and now this is where it gets tricky. So we'll check the last element of, so this was like we had before, right? What is that? Yes. So in this case, what is this? This will be storing our indices. So we need to plug this back into P. So this is something like this. I think that'll work. In fact, I'm going to do this. Sorry, I'm going to do this something real quick here. I think I'm going to change it back to P. And I think this is okay. Enumerate. Okay, so then, yeah. So this is okay. If P is less than or equal to, okay, this is good. And now what do we want to do? So we want to say, okay, we're going to change P, and we know the index, that's this here. That's index. So then we could just use that here. So we can say S of -1. And then we say, well, what? So the value at index -1 should be, well, that. So it can still be this. But we're going to apply our discount to it. Okay, and then we say s dot append. Now we just append I. And then that's, we don't, now, what do we have? So I think we can take this off. We don't need L anymore. And what would happen though now is we can just return P. So let's think about what's happening here. In this case, since there's elements remaining, that would be the same as we've left these, if we go back here, we left these untouched. So we don't need to update them. I hope that makes sense. In fact, I'm going to modify this a little bit. If you notice that this is the same as this, I'm just going to say, well, what isn't the same as minus equals P? That's probably a little bit better. I think that works just like that. Okay, let's run it. What went wrong here? Oh, I didn't pop it. My apologies. So we say, okay, sorry. So s dot pop. We'll just call this maybe the I don't know, I. Sorry, we can just do this here. S dot pop. Yeah. So sorry, this is that. So let's just put this in here. Okay, my apologies. Okay, I'll submit it now. It might be better. Yeah, it's fine. But you really don't need to do it like this. But let me just go over this again. So that's why I went over this 2 times. The first time is more maybe like educational or more The other type is more of like what you would want to present in a work environment where you need where other people need to read your code and understand how to maybe modify it if need be, or even fix a bug. So when your code is more readable, it helps other developers and even yourself. So looking at this, it isn't quite clear what everything is, and but I did want to go over just to show you that sometimes writing your code in a more succinct manner maybe does add some level of like speed enhancement, and that's fine. Um, but sometimes, as a developer, you should know how to write it both ways, in the more legible way, and the more maybe I'll just call this more robust, robust way. ROBUST. Okay. If you found this video helpful or educational, please consider liking or subscribing. Have a wonderful day. Take care of yourself.